always check out the Level 1 Tech's motherboard reviews for any kind of system that you're building or doing fun, exciting things with. This is the X870 No E Nova, Phantom Gaming X870 Nova Wi-Fi. We've taken a look at the X870E Nova Wi-Fi from ASRock, and this is where things start to get interesting. I saw some interesting motherboards at Computex, and would you believe that this motherboard has dual PCIe Gen 5 M.2 slots direct to CPU plus 16 lanes of Gen 5 also direct to the CPU plus the regular chipset connections, which is, PCIe 4.0 by 4 to fan out into all the other USB peripherals and everything else. Yes, it is possible on AM5 with your 9000 series Zen 5 CPUs. And that has fallen under the radar and I think is interesting. But let's talk about the design choices and how it was difficult to launch boards with these capabilities on launch day because of some requirements that AMD had. But first, let's take a look at the motherboard and, do the motherboard review and get it set up on the test bench. And there's a few things I want to show you. What's not exciting about this motherboard is that it would be nice if it had more PCIe slots, but what are you going to do? All right, so inside the box, you get your Wi-Fi antenna. It is the simpler Wi-Fi duck, like a rubber duck antenna, is what I call them, as opposed to a movable Wi-Fi antenna. It would have been nice to see. I mean, this is not the least expensive board option from ASRock. It would have been nice to see a better Wi-Fi antenna solution, especially because we're rocking the Wi-Fi 7. In the box, you get the board. Isn't that attractive? Also, in the box, you got a Phantom Gaming cherry stem style keycap, some quick installation guides, some RGB breakout headers. So you can, it's a Y cable basically for your RGB. That's a digital RGB header cable. Makes it a little easier to cable. And two SATA cables. Two? No, one. Two. And two SATA 6 gigabit cables. Okay. So this board, 18 plus 2 plus 1 power phases, it actually has 5 M.2 ports. If you check the manual, one of the M.2 shares its 4 lanes with the 4 SATA ports. So if you need to use SATA, don't use that M.2 port. It's like the middle of the board one. And yes, but 2 of them are Gen 5, but there's a gotcha. We'll talk about that more in a second. It does have a metal backplane on the back. To get at the M.2, you're going to have to remove some screws. It's not quick release or anything like that, but there is an easy release for the GPU, which we'll demonstrate in just a second. I've also added a little bit more clearance to the USB-C connection, which I really like. Sometimes this can crowd out, it's a little too close to your GPU, especially if you've got a long GPU, but you got enough clearance in this configuration. You got dual 8-pin power for the CPU, plus regular ATX 12-volt, a built-in power and reset button with diagnostic LEDs, which is always nice to see. 3 4-pin fan headers at the top edge of the motherboard, 4 4-pin fan headers at the bottom edge of the motherboard, right angle 20-pin, 5 gigabit dual USB header. You got 2 SATA ports at the front here. This bottom, a physical X16 slot is an X4 electrical. That's PCIe 4.0 by 4. That would be appropriate for a capture card, up to a capture card. You could also run a 25 gigabit NIC off of this. It's got a built-in 5 gigabit NIC, which is based around the Realtek chipset. And then we've got quite a lot of USB connectivity at the rear. Let's take a look at our rear I/O. We've got HDMI out, CMOS clear. We've also got the BIOS flashback button, our Wi-Fi 7 antenna connectors, which are normal. You can use an aftermarket Wi-Fi solution for this. We've got 4 USB 2.0 ports. We've got 2 ultra power ports and 2 lightning gaming ports. And we got 2 USB 4 ports. Then, of course, we got another 5 gigabit type A port, analog microphone in, analog audio out, and an optical SPDIF port. The rear I/O shield is built in, which is nice. It's always nice to see that. Yes, this is Thunderbolt compatible. So this is nice to see. You can plug Thunderbolt peripherals in here. This uses 2 of your PCIe 5.0 lanes back to the CPU. So for that second M.2, if you want to run it in 4-lane PCIe Gen 5 mode, it will disable your USB 4 ports. See, that was one of the requirements from AMD. AMD really wants to push and tout their USB 4, their Thunderbolt compatible. It's not Thunderbolt, but it's Thunderbolt compatible USB 4 solution. And there is a direct path to that into the CPU, because there kind of needs to be, because they experience what I experienced working on the KVM, which is some USB chipsets kind of sus. And the USB ports that are built into AMD CPUs tend to be head and shoulders above what you would get in a chipset, a USB chipset configuration. And so these USB 4 ports are basically direct lanes back to the CPU, which is very nice. And they're 4 lanes each, and so there's a little bit of muxing because it's PCIe Gen 3 speeds, but don't even worry about that. Basically what I'm telling you is if you want to rock dual PCIe Gen 5 M.2 at full Gen 5 speed, 15 gigabytes per second, you can on this board, but you're going to have to live without your USB 4 ports. If you want both, you can. It's just going to be 2 lanes of Gen 5 for each one, which means you're going to be limited to about 8 gigabytes per second on your fancy pants Gen 5 M.2. We do have a quick release for the primary blazing, that's PCIe Gen 5 and ASRock vernacular M.2, which is right above the GPU, so you can get adequate cooling. Giant heatsink. If you have an M.2 that has a built-in heatsink, of course, you'll be able to use that in this slot, no problem. And it is toolless, even toolless M.2 installation. Very, very nice. Now, in terms of power delivery on this board, it's overkill. You could deliver up to 200 watts, well, really 230 watts to your AM5 CPU, but as a practical matter, 195 watts with an overclock on like a 9950X is all you're really going to see. You can overclock the 9950X 3Ds this generation, but it helps you with multi-core. It really doesn't help you with gaming or lightly threaded workloads. You don't get more frequency out of it. Listen, with the 5 gigabit LAN, you can do 500 megabytes per second off of your network. That's as fast as SATA. If you're using SATA for bulk storage or anything else, you really should check out some other videos on the Level 1 Tech's channel that has to do with NAS, like building a NAS, network storage. Because at 5 gigabit, it's a very similar speed than you would get from SATA. It's a little slower, but not really, not as a practical matter. And not having to deal with, slow stuff. Now, if you're talking like a mechanical hard drive, oh yeah, you should just mechanical hard drive network attached storage. That's the way to go. You don't need spinning rust adding heat and noise to your desktop computer. That's just silly. Now for our build, we're also going to be using the ASRock Steel Legend 9070. This is the non-XT version of this. I've noticed that lately they've popped up for pretty good pricing here in the US. Don't know if that's pre-tariff imports or what. A couple months ago, it was hard to recommend the non-XT over the XT variants because if there's like a $20 price difference between XT and not XT, you should always go XT. Safe slot. There's the safe slot. And then, boom. Easy to remove. Boom, there we go. Oh, you might have noticed we're missing memory. The other fun thing about motherboard refreshes is that the motherboard companies learn. They learn from their mistakes and they learn from things that enter the market that were not available for testing. Things like 64 gig DIMMs, things like high capacity error correcting DIMMs, things like high speed DIMMs. And so this being a new design that is just released at the time that I'm doing this video, at the beginning of August of 2025, the ASRock has incorporated lessons learned in power delivery for the CPU, refreshes and updates from AMD for the 9000 series CPUs, and because there's new CPUs coming. It's always a constant thing. F series. Excuse me. And we've also got fast memory like DDR5 8000. And while you really should be getting a higher end motherboard if you're going to go insanely high end memory, DDR5 6000 is still the sweet spot because of the 2000 mega transfer memory, like Infinity Fabric and the relationship between the memory clock and Infinity Fabric. That's still true. So if you're going to build a 9800X 3D system around this, or like a 9950X 3D, or a 9700F with a dedicated GPU or whatever, then this is, at the time that I'm doing this video, that's unconfirmed, by the way, the F series CPUs, but it's on the list. You can also check the QVL list for memory and CPU, but the QVL list is like the qualified vendor list. And so it's like, oh, we tested this memory. It's usually not very comprehensive, and you can usually get away with things that are not on it unless you just don't have time. So G.Skill has the Trident Z Expo kits. Expo is a memory profile that is appropriate for AMD. AMD's platform will use Intel style XMP memory profiles, but the Expo profiles you usually will get a little bit more performance out of your memory kit. And that is really good if you're building a gaming PC or anything else like that. ASRock also is generally pretty good and one of the most permissive board vendors in terms of what they have unlocked in their BIOS. And so they tend not to lock or hide anything away. They have their own overclock menu and their own advanced tweaking menu, which has a lot of cool stuff in it. But they generally don't lock out any of the options from AMD's own menus, AMD's CBS and PBS menu. And that's not necessarily true with other board vendors. Sometimes other board vendors are trying to stuff their own special sauce in there. So I can tell you that the DDR5 6000, like normal gamer memory, all of that works great on this platform. The thing that I was interested in testing is 4 DIMMs. 4 DIMMs can be really tricky to get working. If you're going to do a 4 DIMM configuration, I recommend getting the exact same memory kit and ordering it at the same time. If you start with 2 sticks of memory and you add 2 later, you're going to be in for a lot of trouble. If you start with 2 sticks of memory and you add 2 later, that can be a lot more troublesome to get working, especially at speed. The design of DDR5, the electrical considerations, and like how fast it is, make it difficult to qualify and test and cover every corner case, every special case from mixing different kits of memory. You're better off from a matched kit of memory. And even then, you know, the platform AMD only guarantees up to 3600 in some scenarios, which is a far cry from 6000. 4800 and 5200 are have been attainable for most people on the forum. But generally, as a rule of thumb, the newer the board is and the more sort of design revisions that are in the board, the more luck you're going to have. And so this is an X870 board, not X870E, and it has the lessons learned in it. It's a second half 2025 board. This is going to be a pretty good option for some of those. Like, I'd like to use 4 DIMMs. I can also tell you anecdotally that 4 sticks of 48 gig DIMMs is easier, all matched of course, is easier to get working than 4 sticks of 64 gig DIMMs. And if you're looking at 64 gig DIMMs, pay attention to the CAS latency, the CL numbers, because right now the 64 gig DIMMs that are on the market have a much higher CAS latency, even though they're clocked really high. So if you have 2 kits of DDR5 6000 and one of them has a CL28 and the other one is CL42, the CL42 is much, much, much slower as a practical matter because it has to wait 42 cycles of, even though it's running at 6000, even though both kits are running at 6000, whereas the other one only has to wait 28 cycles. So it's a lot more it's a lot faster as a practical matter. So the 64 gig DIMMs that I've seen on the market and the ones that I have a relatively high CAS latency number. And I have gotten the crucial 4x 64 gig kit that I have to work on some boards. But when I do, it's like 3600 to 4800 and it's got the really high CAS latency. Whereas the 448 gig DIMM, 192 gigabytes of memory total, has a CAS latency of more like 34. And that is, when it's running at its rated speed of 5600, that's a pretty good CAS latency. It's much better than the equivalent 64 gig configuration. And while 5200 is not something that you will get out of the box and be stable, or at least I don't think you should expect it to be out of the box stable. You might be able to get it stable with some fine tuning and some experimentation. Getting 4 DIMMs stable at higher speeds has been front and center on every motherboard maker's to-do list for this generation. So with that said, let's do a couple memory tests. First up, let's just make sure ECC works in the system posts. Now, as part of our fun, exciting memory testing, just to show you, this system is currently configured with 2 64 gig DIMMs. We've got 128 gigs, and it is in the optimal layout, 1 DIMM per channel. These motherboards have 2 DIMMs per channel. There's 2 memory channels, but there's 4 slots, which means you can run 2 DIMMs in each channel. If you have 128 gigs, even if you order another 128 gig kit that is identical later, the temptation will be to put the 2 memory sticks that you have in the 2 empty slots. This is actually not the most correct way to do it, and especially not the most correct way to do it if you have the unfortunate situation of having mismatched DDR5 DIMMs. This has actually been the recommended way to do it since DDR4, which I know some of you are just falling out of your chair and you don't realize this because the memory controllers for DDR4 were just that good. Well, at least in later in life, early in the DDR4 generation, this was what I'm showing you was also true, is also the recommended way to do it. What you're actually going to want to do is move one of your existing DIMMs to be paired with the DIMM that it came with, and then put the new kit that you got also in its own channel. So the kit of memory that you have stays in its own channel, 2 DIMMs per channel. But when you get a kit of 2 sticks of memory, you want them to be together in the same channel when you've got all 4 populated. I'll show you. This is only a single channel of memory populated with both DIMMs. It is ready to receive the second kit of memory. You wouldn't normally operate your computer like this with only, this is single channel mode. You don't want to do this. And this feels a lot like I'm explaining how long you're going to count for the holy hand grenade. Thou shalt count 3, but sorry for the verbosity, but this is important. Even if you order 2 identical kits of memory at the exact same time, this is how you want to populate each kit. 1 kit of memory in one channel, 1 kit of memory in the other channel. And now our configuration is 256 gigabytes on this platform, which historically has been tough to post and be stable. Let's see how it works. I'm happy to report a 256 gigabyte setup here is stable at 3600. Now, if you're rocking an EPYC AM5 CPU, it's not on the QVL list, it does work. We got the 4545P in here. That's a 45 watt EPYC. This board as a off-label home lab type board could make a pretty good fit for your home lab type scenarios. It'd be nice if it had more PCIe slots. PCIe slots are always nice for home lab, but it does have the built-in 5 gigabit NIC. But the 5 gigabit NIC is a Realtek NIC, and so when you're using Linux, you're going to need the latest Linux kernel and firmware because this is a brand spanking new 5 gigabit chipset, and so it doesn't work with older kernels or setups. So if you want to run like Ubuntu 24.04 LTS, it will work, but you're going to have to get a package and a firmware or run a more bleeding edge kernel, get that set up. But otherwise, I'm happy to report, from LSPCI and everything else that it works. Also, there's an option in the BIOS to disable memory injection. That I think this is something that wasn't there before in earlier Agiza, but is there now in the AMD configuration menu because ASRock doesn't hide anything in the menus. And so it's true by default, which prevents error injection to the memory controller, which if you're using like MemTest86, that's how you would not get memory injection to occur. So this is maybe another video that we look at where it's like AM5 and error correcting DIMMs and will it silently correct memory? Yes, but do you get a report to the operating system that an error correction has occurred? Sometimes, but not always, not in every configuration. Now, if you're not running an EPYC CPU and you want to push the memory even a little bit farther, you can do that. There's a thread on the forum, but you still need to play with things like the memory termination strength and that sort of thing. And a lot of those options are locked out in when the machine is in EPYC mode, or at least the easy mode options in ASRock's menu are locked out. You can still get to the AMD CBS and PBS options. You can manually configure the pull up and the pull down for proc ODT on the EPYC CPU, but you had really better know what you're doing if you're messing with memory termination in order to try to get 4 DIMMs to work more stably than 3600. I was able to achieve 4800 on this platform, and it was basically okay. There's weird things that you can run into though, like for example, if you are actually using both M.2 in PCIe Gen 5 mode with full speed 15 gigabyte per second transfers, and you have overclocked your memory overclock might not be as stable as you think at 4800 or 5600 in the 4DIMM configuration when you are that heavily loaded on the I.O. side. It has to do with the I.O. die and Zen 5 and a bunch of other variables. But it is nice to see that, ASRock in their documentation, they say, it'll support up to 8400 OC. And generally for 2DIMM configurations, you can push 8000 on this board, which is nice. I tried to look it up for this video. I think this is an 8-layer board, but as a reminder, if that's not correct or whatever, comment below and I'll hard it and we'll figure that out. But in doing research for this, I was like, I think this is just an 8-layer board. A lot of the more affordable boards are 8 layers, and the more expensive boards get into like 10, 12 layers. And when you've got more layers on your printed circuit board to work with, generally, you can achieve higher memory speed. But this, to be as good as it is shockingly good. So even if it is only an 8-layer board, there are much, much worse 8-layer boards out there. This is really pretty awesome for both the home lab longevity use case, the error correction use case, and also like the gamer OC use case. Like there's a relationship there, in other words. And that's pretty much it for this video. This has been a quick look, as quick as I know how to do, the X870 Nova Phantom Gaming Wi-Fi. This is not the first X870 motherboard that I looked at, but this is the first one that has the cool dual M.2 option by disabling the USB 4 interface. And that's not an option, at least I don't think that's an option that you can get on the X870E, but the X870 boards may actually be a better choice for folks like me that are trying to do all these off-label use cases versus X870E, and probably generally a better choice than like the B series chipsets, because those are more low-cost motherboards. And if it's like I want the memory to be faster, or I want to actually use 4 DIMMs, you get some other features there with the board. So anyway, I'm Wendell. This is Level 1. If you have any questions, I missed anything, or you want me to try anything out, hit me up in the forum. I'm signing out, and I'll see you there.